Hello everyone, this is Mr. Chang, and this is our exciting Math 30-2 class. And I hope you will do really well in this class and get a good mark, and then you can use it for your future post-secondary education. For Math 30-2, it will start off with logical reasoning. This is all math is about. It's about logical reasoning. And then we have a lot of symbol, that is the set notation part, which will help you capture your logical thinking, right? Like we all think, but then are there some way to kind of capture our thinking process? Math is one way, like to write down all those symbol and then like numbers. And then in this particular unit, we'll learn about something called set theory, and then what can we operate on a set. Set basically just mean a set of numbers, all right? And then you can either and put you can have two sets, and then you can have an and or a not operation on them. So here I underline it, like this is what you can have, like and or and not operation on any sets. So we'll learn first what is set. Now we already read through the notes here. Every item in the set is called an element. The whole thing is called a set. And then use a curly bracket to represent the set. And then you use a capital letter to name a set. All right. So a set can be a list of numbers. It could be a description. And you can use something called a set notation. Like in this book, they call set builder notation. Usually we just call it a set notation. Something like this. You are saying you have a variable x, and then this variable is less than 7, and then this variable is all in a set of natural number. N represent natural number. So what are natural numbers start at 1, 1, 2, 3, 4, 5, 6. So less than 7, not including 7. Otherwise, they will have an underline there. So this set, if I spell it out, will be just 1, 2, 3, 4, 5, 6. Okay. So just another way. Oh, wow, that's what on top here. So all these three ways give you the same set of numbers. So you read the following, the set of, right, the curly bracket, A is a set of, the straight line is such that, I have a set of X such that, X is less than 7, and this is C is a member of. Now be very careful with this symbol. Don't mix up with another symbol, all right? This symbol work with a variable. You can say a variable, like for example, X, is a member of some set. But this symbol is a set operation. So we'll look at that in a minute. Well, you read that already. This symbol means you have two set of number and one is a subset of the other. So this thing work on set. Oh, okay. This thing work on set. This thing work on a variable as part of a set. Okay. So the first one here compare two set. Here you have a variable in a certain set. So when we will look at some differences. Um, I'd like to thank you, River, for bringing up a question about this expression here in example 1. Like, how do you read this? What does that mean? Okay, so thank you for paying attention to that. Let's look at what Q is. Q is even whole number. Whole number includes 0. Even whole number less than 10. So if you spell it out, that's the set. Okay, less than 10, so you cannot include 10. So this set has 5 elements, namely 0, 2, 4, 6, 8. Now, what is a set notation? How can I write it differently? Well, since they are all even number in math, if you multiply any number by 2, it will guarantee that will be an even number. Like no matter what e is, if you multiply 2, usually they use the form x. Okay, so let's write 2x. In math, when you see 2x, it represents even number. How come? Because no matter what x is, when you double it, it will be even number. And how do you represent an odd number? Easy. Well, it's not easy. It's this way. You start with an even number and you add 1. All right, then you get odd number. No matter what x is, odd or even, you square it, you multiply by 2, so it's even, and then you add 1, then it's guaranteed to be an odd number. So in here, it just say q, you can use x, but they just use e here. They just use those are just variables. You can use anything. You can use like t if you want to. Okay, you have a variable. This variable is defined to be 2x. Well, why 2x? Because if you have 2x, which means it's guaranteed to be an even number. And that's why they use the letter E to represent it. Okay, so here, what is x equal to? Well, x is between 0 and 4, and x is whole number. So if x is between 0 and 4, so if you spell it out, it will be 0, 1, 2, 3, 4. And then now what is E equal to? E is double x. So if x is 0, 1, 2, 3, 4, right? And now that's x. And now E is, you double x. So you just double all the x element here. Then you have 0, 2, 4, 6, 8. That's exactly what you want to define. So that's how you define it. Okay? So it's a bit long, but this is how mathematically, without using words, you can define the first few, like you can define even whole number less than 10. Basically, the English equivalent is this. But mathematically, we write all that. Okay? Now let's move on. So we did all this, right? Like we have all this symbol, um, universal set, subset, empty set. Empty set is just a set with no element. Complement of a set is all the opposite. Universal set is anything, all the elements that could possibly in the set. So, like we have this example, if we are dealing with natural number less than 20, that is our universal set. All natural number within less than 20 is universal set. So all A and B will be part of the universal set. So in here, like since A is a set, universal set is a set, we can use this symbol, which mean, right, they are in the universal set. If you're talking a particular element, let's say, um, then you can use this symbol. Like that symbol is for a it's part of element. We'll look at it. Well, let's look at more example. We've done that in class, we kind of. So let's look at more example, then you will see. When you have two sets, you can also, okay, well, let's look at example that River asked. River asked question number 4. So let's look at that. Question number 4. A, B, C, D are sets, okay? And these are the elements. Which of the following is true? You say element Q is in the set of A. Like remember, this one is a member of. This one is member. All right, is member. And this one is subset. You can only talk about subset when both of them is a set. So if you have an element, you can't talk about subset. So it's not true. So false. When you have a set, you can talk about a member of. So this is false. So right away we get rid of those. Like Q is an element, but when you put a bracket, do you remember what does that make it? It make it into a set. So a set, you can only think about is a subset of another one. You can't say a set is a member of. So this one is a false because you have a set here. Okay, so those are the one that will be, and same for here. Okay, well you can say it's an element, so that's true. Okay, so let's go back. Something happened here. Okay, so let's try. All right, so it says here. Okay, just ignore all that. Is Q in the set of A? Yes, it is. All right. Is this set a subset of A? Well, it is, right? This is a set. Is it a subset of A? It is because this is in A. So it's true. This element is not a member of set C. Oh, that's true. Okay, this set is not a subset of D. Well, but Q is in D. This one, it will make it into a set, right? This is a element, right? But that is a set. Is this set not a subset of D? Well, it is a subset of D, so it's false. Okay, so because Q is part of D. Is A a subset of B? So is Q in the set of this? It is, so true. Is B subset of A? No, right? You can't find the element in B in A. So A is a subset of B, but B is not a subset of A. If they happen to be subset of each other, they must equal to each other. Otherwise, it won't be subset of each other. C is not a subset of D. Okay, well, it is not, right? Because to be a subset of it, you have to have all of the elements. Even though the element S is the same, but it doesn't have element R. So it is not in a set of D. It's not a subset of D, so it's true. Is D subset of D itself? Of course, it's always true. If an empty set subset of something, always true. Okay, so those will be the answer. So TFF, TTF, TFF, TTT. Let's check the answer. So, oh, well, they only show it this way. A, D, E, G, J, K, L. A, D, E, A, D, E, G, J, K, L. Okay, we're right. Okay, let's go back to our notes here. Besides all those subset and element, right? So we are learning something called intersection and union. So when you have two sets, you can join them together or you can take the common one. The intersect mean like you have one set here, you have another set here. Intersect mean, hey, where they overlap, the common one. Intersection is called A and B. They have to both exist in one and the other. The symbol for and is like this. All right. It's the set of element that is in both. Both. So write the intersection set between E and L. Which element are in both? So the intersection between E and L is 0, 2, 4, and 6. This element appear in both. Now what is a union? Union is joining the two. Joining the two. And then everything. Alright? As long as they're in one set, they're in the other. So the union between E and L, union, just think of a U, right? So this symbol is for union. The other symbol upside down is for intersection. It's all the element. So 0 appear in both. You need a 1 because 1 appear in L, so you need it. It's a union. So anything include there, you include it here. And then 2, well, 3, 4, 5, all right? And 6. It's like the smallest set that contain everything. And then there's an A in element set E as well. So this is a union set. Two sets are said to be disjoint if they have no element in common. So if the intersection is an empty set, then they're disjoint. So which two of the set from ELO are disjoint? So let's take a look. Which one have no element in common? O have no element in common with E, but then O have common element with L, E have a common element with L, so O and E have no common. Okay, so O and E are disjoint. Okay. All right, last example. Okay, so when you see this symbol, what does that mean? Intersection, things that's common between A and B. So between A and B, what's common is only 15. All right. But then the union is a lot, it's everything. So I'll write down the answer here. So here we go. When you write the answer, write them in order. Finally, what does that symbol mean? Do you remember? It's not A. So if it's not A, right, it's any number not A. Natural numbers start at 1. So anything number not A will be 1, 2, right, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. Less than 20, so not including 20. So that set intersection with B, so what's common with B? Well, 5 and 10. Okay, so that will be the answer. Write a set equivalent to B. Okay, I'll just write the answer because I'm running out of time. So for the following, I'll just write the answer and then you try to learn from that, okay? Because I want to keep the video short to 15 minutes. So I only have 20 seconds left. So B union C, intersection C. So I'll just write all the answer here and then you can refer to it, okay? All right, so here's my answer for BI when there's no element, there's empty set. All right, Tried it and try the homework. Have fun. Bye bye.